Okay, so it's now time just for a mini challenge. We have another challenge that will be coming up in a later video. But for this one now, looking at the code, why did I actually declare lock file at the start of the method? That's the code that's on line 19. Why did I declare it there instead of actually, say, coming into here on line 21 and doing something like file writer, lock file equals new file writer, and actually doing it there? And obviously we've got an error here because we've already defined it. But what's the reason that I chose to put it in here on line 19 instead of actually doing it within the try block? So have a think about that, and if you know the reason, well, when you've figured out the reason, come back and unpause the video, and I'll show you or tell you what it was. So pause the video now. Okay, so did you figure out why we wanted to do that? Well, the reason we had to do that was that try, catch, and finally blocks introduce new scope. So a file writer declared inside the try block would not be available in the finally block. So if I actually deleted this code on line 19, we find suddenly we get errors on line 30 and 33, and that's because try is a block of, in its own right, and the finally and the catch are also their own blocks, and consequently any variables you define in a given block aren't available to another block or inside another block. So that's why we did it that way, to get that to overcome that, and we did it outside basically the first block. Now you might be looking at this code and thinking, there's quite a lot of code in that method to write out our data, and most of it's concerned with catching the exceptions that the file writer might actually throw. So I mentioned in the videos on exceptions in this section that there really isn't much point catching an exception unless you're going to do something about it or with it, and all this code is doing at the moment is printing out a stack trace. So what we're going to do is we're going to use very similar code to read the data back in when the game starts, and if the game data can't be loaded, then the rest of the game isn't going to work very well. So there's really not much that can be done when a file can't be opened. So the best thing we can do here in that situation is to send the exception back to the calling program and alert the program, or the user I should say, to the error. Now I actually said at the start of the program that Java insists that we handle checked exceptions, but there are two ways to handle them. Now as we saw, doing nothing wasn't an option, but the alternative to catching them is to throw them back up the call stack. Obviously, as this main method is the entry point for this part of the program, we don't actually have any calling code that can handle the exception, but the idea of throwing the exception instead of catching it is very useful. So we're going to have a look at now at how to do that. Now the Java documentation uses the term catch or specify for dealing with checked exceptions, and this means that the method must either catch the exception or specify that it's going to throw it, or that it throws it. Now often it'll make more sense to specify rather than catch, so we're going to do that with our main method. So let's actually have a look at doing that now. So what we do is we come into our main method and we adjust this, and at the end, after the arguments and after the closing bracket, we type throws IO exception. So we're basically specifying that the main method throws that exception, and now that we've actually done that, the caller knows that an exception can be thrown from this method, and because IO exception is a checked exception, the caller then must either catch the exception or also specify that it's going to throw it. So we'll actually, at that point now, we can also remove this part of the try catch block, because we're not actually dealing with the IO exception as such anymore. We're actually just throwing the error. We'll leave the finally block in because we still want to actually process the correct closing of the file. So we can close that one, but we can also close the second one as well, because again, we're throwing the IO exception. So I'll come down here and get rid of that one as well. And actually, I should have left the brace in there. So we close the try off, and again, we've got no catch. And as a result, we can actually change our block now to remove the try altogether, because we're throwing that exception. So you can see the code's been made easier now, because if there is an IO exception that's thrown in the finally block, it is actually going to be thrown back to the, or thrown up the call stack, because of the reference we made on line 18 with throws IO exception. So we still do want that finally clause, because we do want to actually test to see whether we're closing it properly, and if we've got a lock file reference, we do want to actually try and close it. So that's why I'm leaving that finally clause in there. But in some scenarios, with the way we've defined this now, if you're throwing the IO exception, you can probably do without a try block altogether, because you're basically passing on the responsibility for dealing with the IO exception, in this case, to another method. But in this particular example, we're actually leaving the finally clause in because we're actually doing some processing just to check to see whether we can close the file. All right, so let's actually delete locations text again. So I'm going to delete that. I'm going to delete it before we're going to break it yet again. So click on OK. Click on Do Refactor, which will delete it. Okay, you can see there that IntelliJ was smart enough to know that that file was being referenced on line 21, but we removed it, so that's fine. Now, I mentioned a few ways that this code could break, including insufficient permissions on the file, or if it's containing directory and the file being read-only. But we can actually also break the code by deliberately throwing an exception to simulate something, so that something's gone wrong. And that can be something that's very useful to be able to do. So we saw how to throw exceptions in earlier videos, but and as a result, I'm going to throw one within the loop that actually writes out the data. So let's come down to the line after line 23 that's writing the data, and we're actually going to throw an exception there. So we're going to type throw new IO exception, and we'll put a message in there, test exception thrown while writing, like so. And leave everything else as it is. And doing this, actually throwing your own exceptions, can be a really useful technique while testing, but obviously you wouldn't want to leave the throw statement in the code when the code went into production. Now you can place throw statements in code that you want to test to make sure that your catch and finally blocks do actually work, but make sure again that you actually delete them immediately after you've actually tested to avoid the situation where they're actually in production code. And I have seen scenarios where that's been done by mistake in the past. So if we actually run this now, so let's go ahead and do that. We should find it creates the location file and then still successfully closes it. So we get a test exception there. And you can see locations.txt was actually created. And if we open that up and have a look at it, we can see we've got the first entry, the first location, and that's consistent with going through the for loop and writing the first location and then actually throwing the exception. Then note that the finally clause or the block got invoked, and we were able to successfully close the file because that was invoked first before basically after the IO exception was actually raised. So it's, in other words, it still actually processed the finally clause to close down the file. So you can see again, this is a very useful technique, and I'm going to be using it again as I look at different ways of performing IO operations. For now though, I'm going to delete the throw statement so that our code works again. And again, if you are testing this, make sure as soon as you've tested it, you sort of comment it out or just delete it altogether. So I'm going to delete it in this case. So we've now successfully written the locations data to a file, so it's actually time to also write the exits. Now the old way, before Java 7, would involve creating a new file writer object for the exits file, then writing the exits for each location in a loop, similar to what we've done with the loop for locations. And then finally checking that the file writer object is not null, and then closing it with a finally block. Now, the code's already a bit messy, and that would make it worse, slightly worse, but Java 7 added a try with resources statement that actually makes everything a lot cleaner. And I just want to alert you to the documentation for this. It's quite useful to have that as a resource. So let's just go in there quickly, paste that in. You can see the link on the screen there. Suggest you do have a look at that. So the try with resources statement, again introduced with Java 7. So let's go ahead and actually change the code that we've already written to use this try with resources, just to see how much easier it makes our code, or more streamlined it makes our code. And the way we do it is, I'm just going to comment this code all out for now. We'll leave it there so you've got access to it in the source code in the last lecture of this course if need be. So the format we now use is try file writer block file equals new file writer, and it's going to be locations.txt, of course. And it opens up the try, as you can see there. So you can see the format's slightly different with having the file writer object being created in brackets. And then we put our loop. So for location, and locations.value, whoops, lowercase there, locations.value, or .values to be more precise. And then we just do lockfile.write. And of course it's going to be location.get location ID plus a comma, and it's location.get description. And then we add a new line. basically as we had it before. And I'm getting this error here, and if you do get this, that means that we haven't got the right language level set for our project. And you can actually see it's actually saying try with resources are not supported at this language level. So if you get that, just right click your project here at the top, go down to Open Module Settings, flashed up briefly, and here it says was selected version 6, we want to select version 8. But version 7 would have been enough in that case, multi-catch, etc. But we're choosing version 8 because we actually, this course is all about Java 8. So clicking on OK to that should remove that error, and you can see that error is now gone away. So the code's actually a lot neater, and the finally block has been removed because the good thing is with this try with resources introduced with Java 7, it automatically ensures that the file writer stream is closed whether the code executes normally or an exception occurs, which is pretty cool, and especially in this case, where we're actually writing data, it's actually perfect for that. So the documentation that I just called up has a section on the differences in the way that exceptions can be thrown. So it's worth noting that this code does behave differently to the code we just tried out previously, the try finally version. And the differences occur if an exception is thrown when closing the stream in addition to an error in the try block. So in the try finally example, it would have been the exception that was thrown by the close method that was thrown up the stack. But writing the code this way causes the exception to be suppressed, and the exception from the try block is the one that's actually thrown back up the stack. So that does actually make sense, as it's very likely that whatever problem occurred while opening or writing to the stream is probably of more interest than the error closing the stream. So in fact, the first error is probably the root cause of the error when closing, if you think about it. So using try finally, the first error would be hidden by the exception when closing the stream, whereas this method ensures that the first error is the one thrown back, and that's highly likely to be the error that you actually want to be working with. So it's a subtle difference, but definitely worth bearing in mind if you're converting existing code to use try with resources. So I'm going to end the video here now. In the next video, we're going to run this version and just go through what we've done. So I'll see you in that next video.